This is all the information, right, for year 8, the periodic table. Just to start off with, right, so what we've got here is we've got our snaky diagram, which what it does, it starts off saying this is the periodic table. This is then the information that you go through periodic table, elements, atoms, alkali metals, halogens, noble gases, and then a test at the end. But it's useful to know this so you can then do some work before the lesson, so you then know what is coming next. Okay, periodic table itself. You need to know the name of 4 groups. Alkali metals is this group here. Take out hydrogen. So the first alkali metal is lithium. Second group that you need to know about, halogens. Halogens starts here, it's group 7, and it goes fluorine, chlorine, bromine, iodine. Noble gases is group 0, sometimes it's called group 8, helium, neon, argon, krypton. The final one that you might need to know about, but it's unusual, is the transition metals. And this is this big group in the middle of metals like cobalt, nickel, copper, zinc, platinum, etc. Other information, groups go down, periods, from where the name periodic table comes from, goes across. Right, 3 definitions. Firstly, we've got an element. Right, an element is a substance made up of one type of atom. Okay, that's all it is, just one type of atom. So it could be Na, and it's just made of one type of atom. A compound is a substance made of 2 or more types of atoms, but the most important thing now is the fact that they are chemically bonded together. And a mixture consists of 2 or more substances, just like a compound does, but not chemically bonded together. So what you can do is you can basically separate them very easily. Element symbols, right? So what I've got here is, we'll start off with the mass number. The mass number is the number at the top. So I've got 23, I've got 11, oops, can't even do 11, and I've got Na. The mass number is the number at the top, the 23. And what that does is that tells you the number of protons plus the number of neutrons. The number at the bottom, the 11, is basically the atomic number and its number of protons, right? And it's usually the number of electrons as well. And what we'll tend to do is we'll tend to go pen, protons, electrons, neutrons. Protons in sodium is 11, it's the number at the bottom. Number of electrons is usually the same, 11. And the number of neutrons, what you've got to do is you've got to do a little sum, which is 23, which is the big number, take away 11, gives you 12, which is the number of neutrons. Now, electrons. So what we have is this here is kind of a drawing of an atom. The middle contains protons and neutrons, right? So the orange ones there could be protons and the grey ones there could be neutrons. So protons and neutrons are in the nucleus. Flying around the outside, what we've then got is we've got our electrons. Okay, now what was then thought up was that the electrons are then in shells. The first shell here, what it can do, it can contain a maximum of 2 electrons. Once it gets to 2 electrons, it's then full, and then what you do is you then draw on another shell that then can contain a maximum of 8. All right, so if I then just do in black, double quick, so something that's got 4 electrons, what you do is you have 1 there, that shell's then full, and then you have 1 there and 1 there. Just do them opposite because it looks better. Once that shell's full, then what you do is then you draw another shell, and this then can have a maximum of 8. And then finally what you can do is you can have another shell, which then has a maximum of 2, or it can be called 18. Now, that's not particularly very clear, so I'll just do it in orange over the top, 18. It says 2 because normally the biggest one you'll ever get asked to draw is calcium, which will have 2 in the outer shell, but what it actually does, it actually contains 18. Metals and non-metals. right? So metals are to the left of the periodic table. So if I just draw a very, very, very bad periodic table there, right? There's a zigzaggy line that goes down there that was on the previous diagram. Metals are here, non-metals are there. And what metals do, metals form positive ions. So if I was going to draw lithium, I would write Li+. They are good conductors of heat and electricity. They have a very high melting points and boiling points, are ductile, which means they can be stretched, and malleable, which means they can be bent. Non-metals form negative ions. So if I was going to have chlorine, I would write Cl-. It makes a negative. They are insulators, right? So what they do is they keep in electricity and heat. They have low melting points and low boiling points. Okay, so the next important thing is why group 1 metals increase in reactivity down the group. What you'll notice is that lithium, sodium and potassium, if you could see it, have all got 1 electron in its outer shell. Right? Now there are 4 reasons why metals or group 1 metals increase in reactivity down the group. Now weirdly I'm going to start with number 4. Right? The reason why potassium is more reactive than lithium is because it is easier to lose that outer electron. Now the reasons why it's easier to lose that outer electron is because of size. The bigger it is, potassium's the biggest, the easier it is to lose the outer electron. You've also got shielding, right? So what shielding is, where if I've got my positive centre there on potassium and that outer electron, I've got 1, 2, 3, 4, 5 electrons that could possibly be in the way. And what it does, it shields between the negative electron and the positive nucleus. And the last one is, there is less attraction. And again, it's to do with the distance. If I've got positive there and I've got negative there, the distance between, right, reduces when the actual atom itself, the element itself, gets bigger. Right? So, in a nutshell, right, reactivity in group 1 metals increases down the group because it's easier to lose the outer electron, the size of the atom gets bigger, there is more shielding, and there is less attraction. Now, alkali metals have basically got a number of different properties. They are very reactive with oxygen, water, and chlorine. And the other main property, and we just talked about it, is reactivity increases down the group. So basically they are very reactive and they react with oxygen, water and chlorine, and reactivity increases down the group. So the next thing to talk about then is the actual reactions with the alkali metals. Alkali metals react with oxygen, and what they do is they form a metal oxide. So the example I've got on here is sodium reacts with oxygen and it makes metal, which is sodium oxide. They also react with water. When they react with water, they produce a metal hydroxide, I'll show you the formula of that in a minute, plus hydrogen gas. The metal hydroxide is sodium. This group here, the OH, is a hydroxide, so that is sodium hydroxide, and hydrogen gas. When they react with chlorine, what happens is we make a metal chloride. So the metal chloride is metal plus chlorine, which is metal chloride. Now, the next part of it then is why group 7 elements decrease in reactivity down the group. So we've got fluorine, chlorine, and then what we then have is we would then have bromine. Why do they decrease down the group? Because fluorine is pretty nasty. And it works the same sort of way. It's all to do with how they gain electrons. So it's harder to gain an electron on bromine than it is on fluorine because the size. The smaller it is, the easier it is to gain the electron there or there. It's also to do with shielding, just like we talked about previously. So if we've then got the centre of that is we've got the positive there and we've got the negative positive there. To gain that electron or that electron, for the chlorine, there could be electrons in the way. And if there is electrons in the way, it's going to be harder to gain that than it will be that. And the final thing is the attraction. If there's a really small gap between the positive and the negative, there's going to be a strong attraction. If there is a stronger a distance, or the bigger distance between the positive and the negative on the chlorine, there's going to be less attraction. All right, so the reason why group 7 elements decrease in reactivity down the group, right, is all to do with how easy it is to gain the outer electron. Fluorine is very easy, chlorine is not as easy, bromine is actually quite hard to gain that outer electron. And it's all to do with size, shielding and attraction. Now the properties of the halogens, right, they consist of a pair of molecules. So fluorine is actually written F2 because what they do is they bond together by a covalent bond. Chlorine is Cl2, bromine is Br2. The melting and boiling points increase down the group. So fluorine starts as a gas, chlorine is also a gas, bromine is then a liquid, it's one of the 2 liquids on the periodic table, and then iodine is then a solid. So melting points and boiling points increase down the group. And the third fact is reactivity decreases down the group. Okay, the final group is then group 0. Right, now group 0 can sometimes be called group 8. All right, now what group 0 are is they are not reactive at all. All right, now if you think about it, helium, right, what it's got 2 electrons in its outer shell, which means it's full, it's happy. Doesn't want to gain any, doesn't want to lose any. Neon has got 8 electrons in the outer shell, full shell. Argon has also got 8 electrons in its outer shell, full shell. So the reason why group 0 elements are not reactive is because they have full outer shells and they are often called inert.